Okay, good evening, gentlemen. This evening we have Bryan Phillips with us to talk about his company, Amphibious Marine, based near Seattle on the west coast of the USA. So I'd like to ask Bryan to introduce himself and take us forward with his presentation, and we'll follow with a question and answer session. So, Bryan, please take over.
Thank you. As Alan was saying, my name is Bryan Phillips, and we have our workshop in Shelton, Washington, which is about an hour and a half from Seattle, and we've been operating here since 2005, and before that, in 1997, we were up in Anacortes, Washington, which is north of Seattle, and I've been building craft as my full-time endeavor since 1996. So I have a little PowerPoint that I'll turn on here if you like, and I can show you some pictures while I discuss. Let's see. Is this screen sharing working all right there?
Yeah, yes, it is, Bryan. We
Very
can
good.
see it
Okay.
clearly. Thank you.
All right.
Perhaps if I could ask others
Yeah.
to just mute their.
Yeah. Okay. Well, so this first slide sort of shows the old and the new. On the right there is the first craft that I built back in 1993 of Mr. Palmer's design, a Vanguard 14-foot, and then on the left is the Explorer design that I've been building presently. So let's see here. This next slide, it shows a little platform that a friend of mine and I in high school built. Actually, I think this was junior high school. We saw an article in Popular Mechanics that I'm not sure if it was promoted by Universal or not, but the little flying platform. Now the name escapes me at the moment, but I'm sure I'll think of it. But anyway, we bought those little plans, thought it was a touch too complicated, so we set about building this simple little platform, and then with the lift fan we purchased a little universal catalog, and we built the UH-10 T, which is here on this slide. So it took a few years, but we built this one, and that sort of carried me through high school and so forth. But then when I went to college up at Western Washington University in Bellingham, my friend that I worked with the first craft on in high school reminded me that there was some guy in Popular Mechanics that used to advertise up in the Seattle area. So we tracked him down and went for a ride on a new model that Mr. Palmer was building at the time. So if people aren't familiar, Mr. Palmer started building craft back in the 60s, and not just hovercraft, but ultralights and airboats and so forth. So anyhow, Mr. Palmer provided a great deal of education and direction over the years while I was going to college, and I started building his newest design in 1993, which was what you see here. The prototype is there with Mr. Palmer in the background, and this sort of changed my whole perspective on these things, because the Universal was interesting and whatnot, but let's just say it never made it more than 20 minutes away from the boat launch before it needed to return for being bailed out or some mechanical issue or something. So anyhow, this Vanguard eventually would take me on trips as far as 500 miles. So it was just much more practical and useful for what I wanted to do, which was explore. So in this photograph on the lower right here, you may see that we have some steel clamped across the craft. We were experimenting with running the two craft together to see how the differential thrust would work. But one of the things that we discovered running on the river was that inevitably, to keep the craft headed in a straight line, the usual driver responses were to add a slight amount of additional throttle until we both realized we were racing ourselves at a high speed down the river and had to back off. So fortunately, the craft aren't too loud, so we were able to yell across to each other. That craft I built in 1993. This was the shop at the time at my dad's place in Oregon. I just took these foam fiberglass panels, laminated both sides, and built them on this little 4 by 8 foot table under the tarp, which was not really suitable considering Oregon can be a rainy place. But here the craft is finished. It took me 3 months to build it. And so by the time summer vacation was over and I was back to school at Western Washington and Bellingham, I had this craft to play with, and I would go all over the place out in the saltwater with it. You can see from the back in the picture on the right there that many things were learned about dealing with the saltwater, as you can see the rusty frame there. So here's a quick little video that shows the first craft that I built that I was actually selling. Let's see here. Where's the proper button to make it play? Well, apparently there. Okay. So that was a 14-foot craft that I based on the original Vanguard design that had a little Briggs engine on it, but this one has a Kohler, it's fuel injected, and the hull is molded construction. And I had experimented with some vacuum resin infusion at the time, but without the right materials and a good vacuum pump, it proved to be a bit too much. So eventually switched to hand laminating for quite a few years. So this was an unusual day in Anacortes, Washington, with snow. So, and then this is the first commercial job that I got was working with Barry, who got the contract for my local fire department to build, and they were very particular about which model and what color and all these sort of things. So we tried to build something as best we could, but they were kind of trying to drive the design, which was a little difficult. But anyhow, they had this craft in service on the Snohomish River in Falls City, Oregon, Washington, near where Microsoft is headquartered. They had it in service for 20 years before they finally sold it on auction. Eventually, it wound up back here, and I reconditioned a few things, but they used it quite a bit. And sort of at the same time, when I was at school, and then at this point I'd moved away from school to Anacortes, but I had started working on another design that Barry had built, just basically a scaled up version of the previous one that we saw. So from 95 to 98, lots of interruptions, I built this craft here. And here's some construction photos. The little workshop that I had at my rental was 20 foot, 3 inches long. So the craft was built 20 feet long. So, I believe we have a video. So as John referenced, this is the little video clip showing the route that we took to get to Juneau. And this was in the summer of 1998. So there's Barry riding along. We dropped John off with the promise of picking him back up while he took some video. So that craft had a Subaru engine in it, a couple lift fans, and we managed to navigate it all the way to Juneau. These are some of the scenes that John shot on his fancy digital camera. Oh, there's our GPS, Garmin 38. So.
Could I just check, Bryan, if you're sharing the sound or this is without sound?
Well, I don't know. I don't think there's a lot of volume on this particular one. Let me see. I mean, I had it set to for sound, but there it goes. I think the sound though is possibly stolen from the Matrix or something. In 1998, I think you could do that. In any case, it doesn't really allow you to adjust the sound. It's like 2 settings. There's Barry walking the salt off. We had a number of people that provided places for us to stay. These nice folks came and helped offer to get the hovercraft off the beach. They thought we were stranded. We didn't bring a cook per se, so beans. Bears and eating all the grease after the salmon cook. So, I think this video's up on YouTube actually. All right, well, that's just sort of a clip. So, and then here's some pictures from the workshop in Anacortes, which was equipped with lots of rodents and an outlet and a light. So I had to do a lot of work in order to get any work done in that shop. So eventually when I moved down to Shelton here, I built myself a very nice shop with heat and all these sort of things that you need to do fiberglass work. This craft on the left here is one that I built for the Department of Environmental Quality in Oregon. They had an EPA study and they were out doing sampling and so forth. So they enjoyed having a way to get out there as opposed to slogging in mud boots for half a mile out to a sample area. Let's see. I think John was on this trip when we delivered a craft down to New Mexico. It's out at Provo Lake there. And then Green River near Moab, I think.
Colorado River in Moab.
Ah, Colorado. Okay, yeah. I guess the Green is in the area, but joins a little later, doesn't it? Yeah. Thank you, John. So this is an indication of typical customer application here. This is near Seattle, and when the tide goes out, he's got about 3 miles of mud in front of his house. So he has a hovercraft that we built for him, and he's got his crab puller on there and his propane stove. So he goes out, collects the crabs, cooks them up, and brings them back to the house. This is the beginning of a new project here, taking the Explorer that was built design, back in '98, and using new materials and new engines and scaling things up a bit. This was the first one that I had that had a diesel engine. Here's some construction pictures here. And that was all hand laid fiberglass and so forth. So a lot of sanding and finishing work, as you can see in the picture on the right there. So, this was intended for saltwater. So the frames are stainless and the engine got painted and everything for the client. And this one's actually coming back home in a couple of weeks. It's been in Alaska since 2009. and it's going to get a little refurb, and it's going to be providing access to the gates to the Arctic National Park. I guess something you can only do in Alaska. I can't do that here in the lower 48, but with hovercraft being illegal in the national parks. So, but anyway, this is going to be the first lodge in the park in the Arctic, and this is the craft they're going to use to bring people. They use a jet boat for a ways, but then they need this to get the rest of the distance. Sort of a little control panel there on that particular craft. That one has the famous Volkswagen TDI engine that you can't bring into the country anymore. There it is, all painted up and ready to head out into the salt water. It's a cover, it goes over, of course. Here we are out on testing day. So this craft would carry about 1,900 pounds, and that had an 84 horse engine, so the top speed was about 39 or 40 miles an hour. And here's it. It is with one of the small craft. We built, I don't know, about 35 of those smaller craft. And then this is the beginning of a new project. Since that Volkswagen engine became unavailable, I had to redesign around a new motor. So I had to scale the boat up a little bit. And then I had a contract to build 3 of these things. So I decided to build molds and tooling so we didn't have to keep sanding everything. I drew everything in SolidWorks. That kept me busy for long periods of time, trying to design gull-wing doors and all these other things, and building all the tooling. This is just sort of a cross-section here. And here's a little video that shows some of the construction in the shop. So I have a CNC machine, and I can machine molds out of wood and foam and things like that. These are some engine covers. There's the deck covers, foam cores that go into the construction. Oh, that's weird. It restarted there. Okay, next slide. Okay, so this is the deck part, and this is a process called vacuum resin infusion, where we allow the resin to flow underneath of a vacuum bag and wets out the part. The primary advantage for us is keeping weight under control, but allowing us to incorporate foam cores into the construction all in one step. So a process that took me quite a while to perfect, but it certainly makes it possible to make a lot of great parts, and it also helps improve the shop work environment, so I can hire people who might not want to do fiberglass all day, but are willing to do other things as well. So here's the craft out, zipping around. So there's lots of room for the people. And that one mentions heat, but I've also figured out how to install air conditioning as I have clients in various warm places like Seychelles or Texas, things like that. So my wife learned how to fly the drone while riding in the boat looking at an iPad. So not necessarily a little stressful situation, trying to encourage her to get the pictures I want while she says, I'm not going to fly it into a tree. Let me do what I need to do. So that's out by Deception Pass, Naval Air Station, Whidbey Island off in the distance there. And there it is coming up on the beach. I think these videos are up on YouTube as well. So yeah, this is pictures from the tour operation up in Juneau, where they were running passengers from cruise ships out to these glaciers. So Well, there's more of this video available up on the web if you want to have a look. So there's people out for a ride. And yeah, these are some more pictures from the tour operation. So that's a little bit of an education, providing a craft for a client who refuses all training and then, wants to know why they're having maintenance problems. And so we have to try to figure out what's going on, what things I didn't anticipate, like the fact that they were going to do spins in glacial dust so that people would ooh and ah while they ran, 100 pounds of grit through the propeller every day. So yeah, this was another job that I had, building one for a client up in the Northern Territory of Canada, and they were up in the Arctic. And this gentleman actually took the craft on one of the longest trips that they've been on, 1,800 miles all the way up the Mackenzie River to Nunavik at the Arctic Ocean. So he did that all unsupported. Had to bring a few extra cans of fuel to make it. And these are a few pictures of recent work that's been keeping me busy for the last year. There's a picture on the right of an undisclosed location that maybe you can figure out where that is in Texas, but that's where they're landing the craft, and that's me there doing training and so forth. Here's some construction photos from the workshop, recent ones here. Everything these days is made out of carbon, and again with the resin infusion process. So for example, in the lower right there, you can see I've taken carbon fiber, laminated it into sheets, and I'm cutting engine mount parts. The engine manufacturer gives you a 30-pound bell housing, and I can just replace it with a 3 or 4 pounds of carbon fiber sheets to get what we need. So now we are rolling the hull over in the shop with a few hoists and so forth. Let's see here. And I thought a picture with my wife in there would be appropriate, since she handles the most complicated part of the whole thing, which is the paperwork I generate by ordering parts from hundreds of companies and all the challenges that go along with trying to run a business. So I do have a little video I was going to share, but we'll have to pause the recording momentarily. Do you want to do that now or later after the questions?
I've unmuted Bryan, so I think I'd like us to pause the recording, and then you can show show that video, and then we'll restart the recording for the Q&A part. So I'm pausing the recording just now. So recording restarted for the question and answer session.
All right.
So what I'd like to do is ask people. At the moment, I think everybody is muted. So if you'd like to put up your hand, at least in front of the camera, if you wish to talk. Okay, so Mike Mooney is asking the first question. But you have to be unmuted, so please will you unmute? Perhaps it's best if everybody unmutes now.
Can you hear me now?
Yes.
Yeah, Bryan, one of the things I've noticed with your craft, you've got 5 rudders, 2 outboard are larger than the 3 inboard ones. Was there a special reason for that? Because from experience, the shorter the rudder, the more the craft would be inclined to nosedive.
Well, okay. The part of the reason that the rudders appear the way that they are is just sort of an evolution of making things in the shop. So, for example, the rudders that you see in the middle are simply rudders off of a smaller boat. So I just used the same tooling and it worked fine. However, I found that it didn't always give enough rudder authority, so I simply made an additional rudder that's special, cut it in half, and stuck it on top of the outboard ones where I've got the best air, and that gave me enough rudder authority. But if you were to look at the propeller shaft relative to those 5 rudders, you would have to conclude that all of the rudders are rather short, even the outboard ones, because the outboard ones are only perhaps 10 inches above the center line of the propeller.
Yeah, I had noticed that.
Yeah, so I'm attempting to keep them. I'm attempting to keep the rudders as low as possible to prevent adverse roll when the rudders are actuated. But did I understand your question correctly?
Yeah, I understand that part of it, because that was another thing I was looking at and saying, well, they're not as high as the propeller complete. Having said that, if all the rudders were as low as the 3 middle ones, I believe your craft would tend to corkscrew. From experience of a similar sized craft, it did exactly that. It corkscrewed. And that was the reason why. The other thing was, you referred in the film to bow skirt braking. What's that? I know about plough turns and things like that. I've done them. But
okay.
Bow skirt braking's a new one.
Right. Well, the maybe I can move back to an image to assist in the explanation here. Let me scan through my photos real quick and see if I have a front image that makes this apparent. But in the meantime, I will try to explain. So the skirt system on this craft has, let's see, I'm going to...
In your Amphibious Marine video, when you're on the frozen lake, at the end of that video shows you, I think, putting the bow brake on, coming to a stop on the ice.
Oh, okay. Well, where's my zoom controls here? Here we go. Well, we'll share real quick here, so at least I can get to this one. So in the CAD model here, you can see, I don't know if my mouse shows, but in the front there, you see those 8 vents.
Yeah, the panels.
So what's happening is the driver has a foot pedal, and they can open a flap and let air out of those vents. And what you're doing is depressurizing the forward air cushion compartment, because there is a transverse skirt element that separates the stern from the front. And with a little finesse on that, you can adjust the level of drag at the front of the craft. And if you're headed straight forward, we would, that's simply, you can see it in this picture here on that gray skirt it shows. On a black one, it's kind of invisible. But anyway, let me see if I can get to the video John was referencing. Anyway, that is a very powerful control device for us because it allows us to add drag when we want it without having to steer. But then if we combine it with steering, you can do what you saw in that last video. You can pivot the craft in its own length virtually, because of the fact that you've got drag in the front, and the brakes aren't really being actuated there, but you can sort of see them in this video here.
I have an underside view of the prospector showing the bow curtain, the divider skirt.
Okay. Right. Oh yeah. So that's the partition in the front that creates the rear chamber in the back.
Completely understood, young sir. On SRN6s, we used to have what they call dual ducts, one on each corner, and we could either operate them both on one side, both at the front, alternatively corner to corner. So, and we could do the same thing. Although we didn't have them at the front, they're on the side near the front. So it does the same thing.
Yeah.
Deflates the skirt at that area,
right.
whichever you want.
Right.
We use micro switches and not pedals for that.
Well, and without that function that Mr. Palmer came up with, the craft would be pretty uncontrollable. It would just slide all over the place. So
I've done that as well.
Yeah, the first step with us with training is trying to convince people that the pedal is there and that they should use it.
Yeah, we usually say to people about hovercraft, they don't necessarily go the way they're pointing.
Yeah.
And 50% belongs to the craft, 50% belongs to you. If you can gain anything on our 50%, good luck. Right.
Well, and we also have to make sure that the new pilots understand that the throttle works all of the time, the steering works most of the time, and so does the brake. It works most of the time. But you have to understand that there are certain operating conditions in which the rudder is not going to give you everything you need. So you have to do something to correct and gain additional authority from the throttle or something. So, you know, I think this, people learn that in John's business as well in aircraft, that there are situations in which the controls are unresponsive. If you don't understand why, you can't correct that.
Downwind is a good example.
Yeah.
Going downwind, you lose a lot of control over a lot of things unless you're using a lot of engine power.
Mm-hmm. Yeah, that picture John showing sort of shows what happens when the bow skirt is folded back when you're jumping over waves. So
here's that picture that comes up to the main screen.
Yeah, a little higher.
There you go.
There. Yeah. So other questions?
Yeah, Mike Pinder, that is.
Turn your mic on.
You need to unmute, Mike. Can you unmute your microphone, Mike? Bottom left-hand side.
Okay.
We can hear
you.
you.
There you are. Thank you.
Okay, can you hear me now?
Yep.
Well, what power is being developed by your engine?
Well, on the 24-foot craft that we were showing towards the end there, it's a 144 horsepower turbo diesel.
Right. And how many passengers can you carry?
Well, you could certainly seat and operate with 12, but there are regulatory considerations for people running commercial operations, but the craft can certainly handle 12, or about 2,200 pounds is fine.
On the skirt, if you stop on water and float for a bit, do you find the skirt fills up with water and makes
it is a tube shape along the sides and the back, and yes, you can get water in there, but we put foam flotation inside of the skirt to mitigate that. So usually if you've been sitting on the water for a half an hour in wavy conditions, it might take you perhaps 20 seconds or so to purge the water out of the back. And say something, John, so it...
Here's a skirt. The stupid auto cameras messing me up, but that's a skirt laid out on the ground with the flotation foam bonded to the inboard and outboard of the center line.
Oh, thank you.
And there is a drain at the stern, and so as soon as you start the craft up, there's some amount of lift air that leaks out of that hole, and it carries with it any water or dry snow or anything like that might accumulate inside of the skirt. there are some unusual circumstances in which the flotation is not effective. I used to run tours out of a place called LaConner, Washington, and it looks like a river. If you were just to come to town and look out and see the boats, it looks like you're at a river, but in fact you're at the saltwater, and depending on the tide and the current at a particular time, when you tie up at one of the docks, it's very difficult to predict whether the water is going to come from astern or from the front. And if it's coming from astern at 3 or 4 miles an hour, it can overwhelm the flotation and ram water into the skirt. And I went one day to go use the craft, and the skirt was entirely taken shape underwater, rammed full of thousands of gallons of water. So, but fortunately, there was nobody behind me, so I was able to do some clever work with the lines and get the boat swapped ends, and then the current pushed the water all out for me, and I was able to head out.
I used to build a craft 12-seater about the same size, but I needed about 250 horsepower to get over the hump. And so your craft seems to be a lot more efficient with less power.
Well, to give you an example of what it can do, the 144 horsepower engine, the reason we have that particular motor was it's the smallest diesel that I could find that I could import into the country and use. However, when I was conducting a demonstration one day, I had a total of 13 people on board. And at that particular moment, we were under 2 hours of operating time on the engine, and the computer restricts you to less than 3,000 RPM out of the 3,800. So I was able to get it to plane out with about 40% throttle. Because as soon as you go over 3,000, all the little bells go off, and it starts making notes that you're stressing the engine and your warranty is disappearing.
That's one of the reasons for your success, Brian, is the very large diameter propeller that you're using.
Yeah, it's 84 inches in diameter, and then the air cushion is 24 by 11. We lose about 10% or more because of the shape of the skirt. So it's not quite 24 by 11, but the curve in the front and the corners and so forth. But yeah, and other things are, for example, all of the composite parts you see, everything that's white gel coat, all of that weighs about 650 pounds on a 24-foot vessel. So it's keeping the weight under control, because when I put this engine on that I have no control over, the engine weighs 580 pounds. So I can only reduce weight on the objects I can control. And so keeping the weight of the vessel down allows us to build something that can carry more than what it weighs. And I've often wondered what would happen in large craft, 80 feet or something like that, if they could get build something other than welded aluminum. Because I remember going up and visiting in Vancouver, BC, and I think the AP-188 they had there, it weighed about 100,000 pounds, but it could carry 40,000. So it seems like their payload fraction is rather off the mark, considering how scale tends to favor the larger design.
And Brian, if I recall properly, on our trip to Alaska, that 20-foot Explorer had 51 horsepower installed, and the craft weighed maybe 1,100 pounds, but we had 1,200 pounds of load in it, going the 1,400 miles.
Yeah, the engine was 55, and the craft weighed about 1,250 empty. And yeah, at one point, I think we added everything up with the fuel and so forth, we were carrying 1,450. Now, when I went and took that 55 horsepower Subaru 20-footer out on the lake. I don't know if I can find the picture, but I loaded it with trash cans of water that I borrowed from the neighbors, and I weighed everything very carefully. And with the 55 horsepower, I was able to get 2,100 pounds up on step.
Wow.
Now, I kind of stopped at that point because it was planing out in about 15 seconds or so. I stopped because with 2,100 pounds loaded into the cabin, when I went over my own wake, the entire floor was moving underneath of me. And I was afraid I was going to break the bottom out. So I decided that that was enough of that test.
Perhaps what it illustrates is the advances, which obviously, Bryan, you've been making, that a number of others have been working on for the last decade or so, with improvements in glass fiber and carbon fiber construction, because the weight that you mentioned for the hull is very, very light for this, its size and volume, I think. And there's another guy that's just joined us, Owen, down in the bottom right-hand corner, who's also been working very hard on that. I think, Owen, haven't you, to at a smaller size, of course, but minimizing weight and also increasing the diameter of your propulsor to improve efficiency. It's the name of the game, I believe.
The other thing that the large propeller does for us is it keeps the tip speeds down, which is helping in the operation I was showing at the end there, because they're dealing with a lot of grit, and so keeping the leading edges in shape is a lot easier with lower tip speeds. The other thing is the noise reduction. They're able to operate through a rather environmentally sensitive area while not disturbing anyone. They've got a lot of people keeping an eye on their every move, and so it's important that they not make too much of an impact on the area. I think I have the little picture from the payload test. It's not very high resolution. I think that was shown. That was with a Sony Mavic camera with the floppy disk for film.
That's the one we took to Alaska that I shot all the pictures with and uploaded on my 486 laptop over a 14.4 cellular connection.
Yes, I think we were blogging, John, before people.
I think I was doing one of the first world-class live blogging there in the summer of '86 or summer of '98 when we did that. Every time we'd hit a town and we would park at one of the fishing piers, I would try to get a cellular signal. I had AT&T One rate back then, and I was able to hook up the laptop with a cellular modem, and it was 14.4. And that little Sony Mavic taking pictures on the floppy disk. That's basically how we were able to get the data rate so low that we could update still photos at least during the trip, and then upload the video after we got back.
It also allowed for a way for my mom to know that we hadn't died yet. We were admonished by one of the people that creates the cruising guides for the coast for not having radar and a chart table.
A chart table, yeah. Where's your plotter? Somewhere around here, I still have that GPS 38. Barry had one, and I had one, and they operated to where one would go on the fritz while the other one still works. So we're constantly switching back and forth between these two primitive Garmin GPS 38s, which only gave you lat and long, and they gave you speed and heading, but there were no graphics on it like anything of today. But I did a test trial run on a Jeppesen software, and I was able to hook it up to the laptop. And there was a time or two when we were navigating at night. We dropped Barry off at Ketchikan, and it was Bryan and me for the last 400 miles from Ketchikan to Juneau. And we were running late into the night, and I'd be calling out headings and bearings to make it around some of the obstacles in the straits going up that way. It was we got some poor visibility for a while. Alaska is not the pretty picturesque place it always shows in the brochures.
Well, those Garmin 38s were actually the first Y2K failure. They all died in August 1999 because the calendar was would only carry them that far, and now they're just a piece of junk.
Yeah.
So
my MD80 had better electronics than that Garmin 38.
yeah.
But talking about your long journey up to Juneau, how did you arrange your support along the way? Or was it by people you knew, or just come across a place where you can go ashore and try your luck?
The first 2 days we had places to stay because we knew people.
Okay.
But the rest of it was just us picking a spot on the chart that maybe we could get to, and then drive there and see if there was a beach that we could pull up on, or when we wanted a shower or some fresher food, we would stop at a marina or something. But I wouldn't describe what we had as support.
Or if we ran into 12-foot rolling waves, we were like, I think we'll rate this out.
Yeah. Start playing cards or something, because we I think there was one occasion where we sort of got ourselves in a situation where we were a little unsure about whether we had to return to get more fuel or attempt the crossing, and we borrowed a few gallons from a sailboat or something so that we knew that we had a little bit of a reserve. But other than that, we navigated using a marine atlas, which is sort of a tool most boaters use to think about and plan a trip. It's just sort of page by page of interesting places you could go, and a little description of the harbor and whether they have water or fuel and things like that. But it says on every single page that it must not be used for navigation. But when you're going along at 28 miles an hour, there's thousands of islands. You just have to have one person was assigned to keep track on there, and as the islands went by, we flipped through the pages, because otherwise there was no good way to keep track of where we were. So, and the idea that we would have a chart table or a radar, I built the boat on a budget. We had a wiper on the driver's side because I couldn't quite afford to buy a wiper for the passenger side.
So what about now then? You talk about then they wanted you to have a chart table, but I suppose they would, in your present craft, you'd have GPS and the navigation system on a screen.
The ones that I've been building lately, any electronics that are on board, those decisions are driven by the client. So, for example, the most recent one that I built had two 12-inch screens and AIS, which is an automated transponder system, and radar, and a whole bank of LED lights for driving at night, because the customer is all of their activity occurs at night. They're taking employees back and forth to the work site, and that occurs starting at 5 a.m. in the morning, and then starts happening at like 6 o'clock at night. So a lot of night operations through narrow channels and mangroves, and so they have pre-programmed routes that they can keep track of on the screen with both the chart plotter and the radar and the AIS so that they can make sure that they cross the ship canal safely, and then LED lights when they get into tight spots where they need to be able to see whether there's something that's not on the charts.
Okay.
So, yeah, I mean, compared to what I did in the past or could afford, the idea of installing $20,000 worth of electronics on a boat wasn't something I ever contemplated until others started saying, we want this and we want that.
Yeah. Yeah.
But and then air conditioning is been going on a lot of the new ones where people are operating in very warm climates. So I had to design and implement air conditioning system on the craft. So we've got a couple of evaporators, and then the condenser is mounted along with the radiators and the lift fan box. And then I had to squeeze a compressor in alongside the propeller and belt drive system.
How much power does that absorb from the motor?
I think it's about 8 horsepower, and
okay, so manageable.
Unlike your car, I think the compressor is running a lot of the time because we are putting in tinted Lexan and that sort of thing, but getting low E coated windows and so forth is the kind of thing that happens on modern automobiles when they order 100,000 pieces of glass.
Yeah. Yeah.
So there's a lot of window area, and it's not optimized like a modern automobile would be to limit the transmission of infrared and that sort of thing.
Right.
But the craft operates with no wind, obviously, as a reference, at 30 knots with 75 horsepower. So
yeah, it's incredible.
It's not a big thing.
No.
Normally, they are consuming about 3.4 gallons an hour on average of diesel. And other clients who were running the operation where they were carrying the cruise ship passengers, they were down at 2.8 gallons per hour over 1,000-hour periods that I was keeping track of it. Just the ride's paid for, so they don't have any interest in running along at 40 knots.
Yeah.
People want to see things and so forth.
Yeah. Any questions? Yes, Mike. Sorry, Mike Binder.
So how many craft have you built now?
Well, the very small 14-footer, we built about 35 of those, but then quite a few kits. People would get, maybe they wanted the hull, maybe they wanted the hull and the skirt, that sort of thing. The 22-foot version that had the turbo diesel, we built 4 of those. And the 24-foot model that we're spending most of our time on these days, we've built 7 of those. So not great numbers, but keeps me occupied.
And you have some new clients coming up, or
yes, I've got people in a lot of different places that have contacted me, but at the moment I was the past 5 months I was working 7 days a week, 12 hours a day, and so I kind of catching up on a bunch of things. I had a small craft from 94 that was here and got refitted, and then I've got that other one from 2009 coming back, so that'll keep us busy for a few months. And then I've contemplated reinvigorating the small craft with a little bit larger hull, because as these engines have gotten bigger, the 14 by 7 foot hull doesn't make very good use of those 37 horsepower motors that I was using. So I was thinking about building some new tooling and changing the hull size, because I have found that if I build people anything, there's a certain fixed cost to the activity of building them a new boat, and so I need to maximize the performance that they're getting so that they can get some return on their money they're putting in. To put it another way, you know, there is really no way to build anybody a hovercraft in a one at a time sort of operation for $30,000. It's just not even close to what you need with the amount of time it takes to build these things. So I've got to charge quite a bit more than that, and so they need to have something that's going to handle 1,000 pounds or more so that they can accomplish their task.
Bryan, this is Chris here. Thanks for your talk.
Hi, Chris.
I had a couple of questions. The long trip you made, how much time or did you have to deal with any skirt maintenance issues, or what happened along the way?
Well, I recall that with the 20-foot Explorer up to Juneau there, out of the 4 exhaust studs, one of them fell out and it was getting a little noisy. So in Wrangell, we acquired a new exhaust stud, put that in. And then I think there were some little patches that I'd put on to the front corners of the bag. And one of them, I think, was peeling up a bit. And I think we stopped on a beach one day and put a little bit of glue on that to keep that from peeling or scooping. But that skirt, eventually, I got 500 hours out of it, although I've since learned that building a 20-foot craft with 18-ounce vinyl is not a cost-effective way of going. You put too much time into maintenance versus the time it took to install the skirt. So I use more expensive materials now so that we can spend more time running and less time fiddling with skirts. But in general, I find that our skirts usually require seasonal maintenance. So, you know, we put, I don't know, 90 hours on the craft on that trip. And we could have ignored the skirt the entire time, but we chose to put a little bit of glue on for 20 minutes or something to fix a spot. But most of my clients are going, you know, 500 hours or so before they do anything to the skirt.
Do you happen to have an hourly maintenance number, for a general average number for across the board for these craft?
Well, on the 24-foot craft where I'm using urethane coated materials, a typical life that I have seen is something like 1,000 to 1,500 hours. But when one of the ones that I just replaced recently for the client, that skirt made it 950 hours. But one has to remember that when the customer receives a new craft, they've never had one, they've never operated them before, they make bad choices and they ruin this. They put a huge amount of wear on the skirt in the first 100 hours because they kept running over oysters and other things that could easily have been avoided.
Yeah.
So, I mean, I think the shortest lifetime on a Explorer skirt in the urethane material was 1 season, because they just took it on trips across barnacle encrusted rocks and oysters and just drove the thing, but they never looked under the skirt to see if their operation was having any effect on it. But so it's just sometimes people just ruin things. But I've also begun to think that maybe the material that I've been using for the last 10 years, I need to revisit that, because the craft that's coming back this fall was a different brand of material, and it has 1,000 hours on the skirt, and it looks better than my new ones in terms of how it's wearing for 1,000 hours. So I'm beginning to wonder if the material I've been using is not nearly as good as what I could find. So other modes of failure of these skirts beyond just wearing through it are, I found on my original Explorer that even though it had vinyl left on it, it had flexed so many times that the fiber was done, and it was subject to catastrophic tears and that sort of thing.
Cyclic stress.
Yeah. Your question?
Is the kind of thing, sorry, I'd make a comment that what you're just describing, Brian or John, sounds to me a bit like the experience with the lower parts of segments on a segmented or loop and segment skirt, because the lower edges of a segment they flagellate all the time. In fact, in riding the water. And that eventually the fibers just break up.
Yeah. Well,
Brian.
Yes.
Well, firstly, hello everyone. Sorry to come in late. Great to see everyone. Have you played with any more exotic materials like Dyneema or? Well, that's a good start. Obviously, Kevlar fibers.
Well, I do have a patch I think is of a Dyneema material. It's an uncoated fabric, though, that I attempted to bond on for the client. They got this material, they wanted me to try it, so I attempted to glue it on there. But the answer to your question is basically no, because I'm not in the coated fabric manufacturing business. And if you want to have a coated fabric made, typically you're talking about a $10,000 minimum order to get them to coat something, even if it's a different weight of fabric or maybe Kevlar or something like that. The kinds of things that we've been doing for clients are like using two-part thermosetting urethane paints so that they can just paint new rubber onto the skirt.
What about any low friction materials? Have you tried any of that or seen any of that?
Well, basically all I can do is try coated fabrics that are available. So for example, I used Hypalon coated nylon for a while, and it is very flexible and lasts forever in the sun. The wear resistance, I would say, is about 5 times what you can get with vinyl. The problem, though, is that it all has to be hand glued with buffing of the fabric, multiple layers of glue. So I decided that it's not practical for customer repairs, but also manufacturing in the shop. I've moved to thermoplastic materials that I can weld with my heat welding equipment. I have a very large hot air welding machine that I use to do all the seams and so forth. But then the customers can mimic that activity with a handheld hot air welder. So, but glues also work on these materials. So yes, it would be fantastic. I'm sure we could find materials that would last longer, but we would have to find some way to get a manufacturer of coated fabrics to make something for us. For example, one of the things that would be, I would think, a fairly easy request is to say, okay, take your existing production run and materials and everything, and instead of putting an equal amount of coating on both sides of the fabric, how about giving me an 80-20? And then my fabric will have an outside. You know, but I guess that would require a special order and all that sort of thing. So, but it seems illogical to have 50% of the coating on the inside of the skirt where it never sees the sun or anything else.
Yeah, well, we traditionally only run single-sided, so we don't have that issue.
Right. Well, you can't bond things together if you don't have coating on the other side.
That's right. We sew.
But if you're sewing and building fingers, that's not something you're thinking about.
That's right. I guess part of that, my question is that basically we're a bunch of scavengers, aren't we? Like as hovercraft developers and designers. So we're always looking around and just, you never know what you might just stumble across. And I mentioned Dyneema before because, I read with such excitement when I first got to know about it. And I thought, well, this is going to be based on the information or the specifications on it. It's going to be incredible. But, I ordered some from the States and made it into skirts, and it was a total disaster. You couldn't believe something that's promoted to be so good can be so bad, but obviously incorrect application.
Right. Well, Kevlar, I guess the you know, and other materials like that, my primary consideration is how well is the coating wearing? Is the coating wearing through, or is it, how well is it attached to the base fabric, so you don't have delaminations and things like that. But other things that I've done more recently to try to give customers extended life when they do have to deal with oysters and things like that is I buy urethane sheet material, like 20 mil or 40 mil thick urethane sheet, and there's quite a few manufacturers that make that. And then I put it onto my CNC machine and cut it into strips with a knife. And then I butt the ends together and roll it up and make myself a very long roll, maybe 1 inch or 2 inches wide. And then I use my heat welding machine to bond that on, like adding an extra sole to your shoe. I'll heat weld that to the running surface.
Wow. Well, how much difference does that make in drag on the craft, though?
It's not noticeable. What is noticeable is that I just welded 30 pounds of rubber onto the skirt. Makes it hard to lift and move around and stick on the craft. But I have never found that the coating, you know, coefficient of friction or the smoothness or anything is a benefit. We usually find that having some sort of texture or unevenness to the skirt helps break tension as the skirt is sliding across the water. So we've even experimented with gluing little strips longitudinally across the ground contact area to break suction and cut down on drag that way.
Yeah, I would guess it's a little bit like having spray strakes on the hull of a fast powerboat, which also creates a lot of turbulence, which breaks up the dynamics of the hull. But one thing I'm interested in, Bryan, is one of your videos. I think it's on a frozen lake where you do hear a bit of the vibrational skirt bounce as it's going over the ice.
Right. Yeah, I would say that is the most significant penalty with this skirt design is the bouncing on ice. That would be, I would say, the one thing that finger skirts definitely do better. But other than that, it seems like they require a lot more material, and while maintenance may seem easy, I think one spends a lot more time. Well, maybe not the hours, but the frequency of interventions on the skirt happen a lot more often on a finger skirted craft, from my observation, than ours. Ours requires some maintenance where it might be wearing through over time, but I could drive a skirt for hundreds of hours and never look at the thing. But if you have these, you know, rather small finger skirted craft, you know, you might go a few hours before you have to tie a finger back on, that sort of thing. But I think it's a little different situation when you're talking about large commercial craft. Although I don't know exactly how much time they spend doing finger maintenance or how often they have one that needs to be replaced or not. But I don't have a lot of experience with these larger bag and finger operations.
I've got another question, Bryan. I was aware that some years ago you put a duct around your propeller or your fan at the time, and then I see you've gone away from that again. What's your personal experience with all that?
Well, I put a great deal of effort into creating the tooling to make a molded fiberglass shroud. There was some prompting there from Mr. Palmer to try it. and I built at least 10 or so of the small craft with those ducts. And I think there is one out there still operating with the duct on it, but all the other customers eventually came back and wanted them taken off. And the biggest complaint was directional stability. With a 54-inch duct on a 14-foot boat, the duct simply decided where you went and in what direction. So other things were that I found that customers simply had more incidents of propeller damage where they would bang the duct into something and take out their propeller. So I guess I would agree with Mr. Palmer's original statement, which was a duct may be a device for performance, but it really needs to have a guard around it. Because it winds up getting whacked. And so the other thing I found was that economically it just didn't make a lot of sense. We would put a lot of effort into creating a duct and alignment and trying to teach the customers how to keep everything nice and tight and not rubbing and all these sort of things. And then thinking, okay, well, we probably should have built a guard anyway around this thing. On a small boat, maybe more of a consideration than some of these large ones. But the other thing is the propellers. You buy a propeller, and these days we would tend to buy, an ultralight aircraft propeller or something, and it might be off the shelf 74 inches or 72 inches or something like that. Well, to put it in the duct, we run the blade through the bandsaw, cut off the excess, and throw it in the trash. Well, okay, we may have made the thruster a little bit smaller by going from, say, a 72 to a 54, but the duct size isn't 54. It's the outside that matters for clearance and things like that. And we really didn't gain anything over performance over what we could have had if we just left the ends on the propeller and built a cage. So yes, they do increase performance, but only at equivalent sizes. A 72-inch prop gave us exactly what we got with a 54. So in the end, for those reasons, we basically just decided to get away from it. And I have clients sometimes that would take a 14-foot boat with a 28 horsepower engine, and they would go out and operate in a 25-knot wind, which to me would be ludicrous, but they were operating over frozen areas where they weren't dealing with waves, but those winds left them with a complete inability to steer the craft in anything other than upwind. Trying to get the thing pointed downwind, as soon as you came off the power a little bit or needed to go around a corner, that duct would just swing them right around. So anyhow, I don't know if that's enough, but that's why I went away from it.
No, that's good. Thank you. That's your experience with them. So
I can see how they're an absolute necessity and so forth on a very small thruster, but building a duct for something that's 80 or 84 inches in diameter on a 24-foot boat starts to seem kind of ridiculous.
Yep.
Okay. Chris, you were going to ask another question earlier on, or have we covered it all?
The Bryans had some pretty interesting repair locations. One of them where the sun shone 24 hours a day. Any insight on that, Bryan?
Yeah, right. Well, we had a person who built one of the Sevtech designs, sort of an unauthorized copy, and unfortunately a horrific build job at that. But John and I traveled all the way to Barrow, Alaska to try to see if we could help this guy. But unfortunately, the workspace he provided us was a windswept snowbank, not even in
right on the
Barrow. He did give us a parachute to hang up so that we wouldn't freeze to death. Fortunately, the real sealskin boat was downwind because, boy, those things stink when they're new. But anyway, that craft had the guy that built it, for example, he parted out a Chevy Cavalier and he took the fuel tank out of the car, set it in the bottom of the hovercraft, and kept the same fill tube and cap that's on the car, and that just was on the floor. So you just lifted that up, put a funnel in it, and then poured gas in. And the tank was secured to the bottom of the craft with bungee cords. This is just in the cabin. And the computer controls for this fuel-injected Chevy Cavalier engine, he put those in a Milwaukee Sawzall box that, again, he bungee cord to the side of the propeller frame. He also experimented with some interesting metallurgy. He connected the steering shaft to the bell crank with an electric arc welder, but one was made out of brass and the other was made out of steel.
Here we are in the Alaska tundra right there.
Yeah. So 50 miles out in the tundra, the steering shaft broke, and then the guy created a snowcat out of a minivan to go out and fetch it. He took a minivan and built tracks and created a snowcat and went out and towed it back. So, but anyhow, the thing was just he attached components to the craft with duct tape and spray foam to hold things in place. So anyhow, the thing was so far gone and outdoors, it just was hardly anything I could do. So that was kind of a failure trying to help him get that thing going again, but it was certainly interesting. Yeah.
I think perhaps one could call this far out experience, literally. And thank you very much indeed. I think we ought to call an end to this this evening. And so, Mike, Mr. Booney, could I ask you to offer some thanks, and we'll draw things to a close. You need to unmute first of all, Mike.
Yeah.
Great, thank you.
Yeah, thank you very much, Brian. It's been a very interesting presentation, and a lot of interesting facts and figures have come out of it. Again, thank you very much, and thank you on behalf of the Society.
Thank you for the invitation.
Thanks, Brian.